This question comes from Jason, who asks, how long could a nuclear submarine last in orbit? The answer is not very long, but not for the reason I expected. The submarine wouldn't burst. Submarine hulls are strong enough to withstand 50 to 80 atmospheres of external pressure from water, so they'd have no problem containing 1 internal atmosphere of pressure from the air. And the hull would likely be reasonably airtight. Although watertight seals don't necessarily hold back air, the fact that water can't find a way through the hull under 50 atmospheres of pressure suggests that when the sub is in space, air won't escape quickly. Dangerous carbon dioxide buildup wouldn't be an issue, as submarines use CO2 scrubbers that can be run indefinitely as long as they have power. But oxygen is another story. Nuclear submarines use electricity to extract oxygen from water. In space, there's no water, so they wouldn't be able to manufacture more air. They carry enough oxygen in reserve to survive for a few days at least, but eventually they'd be in trouble. The really big problem, though, would be overheating, because space is so much warmer than the ocean. If you're pedantic, that's not really true. Space is, of course, very cold. But if you're even more pedantic, and I am, it is true in 2 different ways. Space in Earth orbit seems cold because it's so empty. Without a warm environment around you radiating heat back to you, you lose heat by radiation much faster than normal. But space in Earth orbit is actually warm. The pedantic reason for this is that temperature is a measure of the average kinetic energy of a collection of particles. And in space near the Earth, molecules can have average kinetic energies in the thousands of degrees. This doesn't make space feel warm, though. When I was a kid, I remember watching my dad use a metal grinder. Whenever metal touched the grinding wheel, sparks flew everywhere, sometimes falling in a shower on his hands and clothes. I couldn't understand why they didn't hurt him. After all, the glowing sparks were several thousand degrees. I later learned that the reason the sparks didn't hurt him was that they were tiny. The heat they carried could be absorbed into the body without warming anything more than a tiny patch of skin. The hot molecules in space are like the sparks in my dad's machine shop. They might be hot or cold, but they're so small and there are so few of them they don't change your temperature very much. Instead, your heating and cooling is dominated by how much heat you produce and how quickly it pours out of you into the void. And this is the practical reason that space is warm. Without air or water around you to carry heat away from your surface, you don't lose heat by conduction or convection, just radiation, which often isn't a very effective way to cool down. For most human-carrying spacecraft, the big problem isn't staying warm, it's keeping cool. And a nuclear submarine isn't just carrying humans, it's carrying a 200 megawatt nuclear reactor. It's hard to get good numbers on the efficiency of nuclear reactors in military submarines, but a conservative guess based on civilian reactors is that around half the reactor's energy, or around 100 megawatts, is lost as heat. This heat is normally dissipated by seawater, but again, no water in space. Without cooling, a 200 megawatt nuclear reactor outputs enough heat to warm the entire submarine by about half a degree Celsius every minute. The submarine would become too hot for human survivability within an hour. But the nuclear reactor isn't designed to warm the submarine in this way, so instead the heat would build up within the reactor and lead to a meltdown. It appears keeping a nuclear submarine in orbit is a bad idea. But to get out of orbit, the submarine would need to slow down enough that it hit the atmosphere, which would slow it down the rest of the way. Without rockets, it has no way to do this. Okay, technically the submarine does have rockets. The problem is they're not attached to the submarine. Launching the missiles won't meaningfully propel the sub. But they don't need to be attached. They just need to be turned around. If the ballistic missiles carried by a nuclear submarine were placed in the tubes backward, they could each change a large nuclear submarine's speed by about 4 meters per second. A typical deorbiting maneuver requires in the neighborhood of 100 meters per second speed change, which means that the 24 Trident missiles carried by an Ohio-class submarine could be just enough to get it out of orbit. Now, because the submarine has no heat-dissipating ablative tiles, and because it's not aerodynamically stable at hypersonic velocities, it would inevitably tumble and break up in the atmosphere, the debris disintegrating in the air or plowing into the ground at several hundred knots. If you tucked yourself into the right crevice in the submarine and were strapped into an acceleration couch, there is a tiny, tiny, tiny chance you could survive the rapid deceleration into the atmosphere. Then you'd need to jump out of the wreckage with a parachute before it hit the ground. If you ever try this, I have one piece of advice that is absolutely critical. Remember to disable the detonators on the missiles.